Hello everyone. So this lab we will talk about how to use HSM works to generate toolpaths and CNC machining. We'll also do the simulation and generate the G code. So in order to do that, we're going to use the faceplate as an example to do it. First, we need to open the file of the faceplate. Alright, so after we open this file, and we can see there are several tabs here, feature, sketch, evaluate. We just go to the last one, CAMs. So CAM is short for computer-aided manufacturing, and there are several different functions. For example, drilling, if you can drill the holes, simulate drill the holes, and also define 2D milling, including face milling, pocket, contour, slot, thread, and also circular, bore, trace, and engraving, chamfering. Several different operations you can add for your machining operations, and also 3D milling. There are also some other operations. Turning, same. So in our case, we mainly use 2D milling and also the drilling. The first we are going to do is to mill the numbers, and then we're going to use drills to create those tapped holes. Now let's create the first operation. We'll do the trace, 2D milling trace, and then it asks us to select elaborate tool. First, we need to choose what kind of tool we want to use for milling this the letters or the numbers. You choose the library, and you can see there's a pop-up box here, and with pop-up box you can go to sample libraries. In the sample libraries, there are several different operations. For example, holders, and then it says inch, metric, sample turning, tabs, or tutorial. So in our case, we use the inch and aluminum. So because the work material we are using is aluminum, so we choose inch aluminum. And if you click here, you can see on the right there are many different tools listed. There are drills. If you could scroll down, you can see also flat end mill, ball end mill, bullnose end mill, chamfering, those. We're gonna choose 1/8 ball end mill. So 1/8 ball end mill, and select. We choose select. You can see it asks us to choose feed rate and also speed. So currently the spindle speed is defined as 10,000 RPM. Sometimes you can choose smaller RPM, for example 5,000 or 6,000 for some rapid processes like engraving or high speed cutting. And also you can define feed rate here. Alright, now let's look at the second tab. This is a geometry. So this shows what kind of geometry do you want to do for this operation, for this trace operation. And we want to mill all the letters, so all the numbers. So we choose these numbers. Remember, we only choose the numbers, not the holes. Now we can choose first these letters, the numbers. Now you can see these 5 letters are selected, and then we can keep choosing another 5 letters or numbers. And then the rest too. and this one. Alright, we have chosen all the geometries. We can keep looking for other tabs. For example, this tab is heights. So these heights are when the machining tools start machining, and then it won't be always on the surface, so it will extract back to a certain height. If you move it a little bit here, you can see this is the extract distance, how high the tool will extract to move to another location to keep machining. And this is you can define it here. Here is a trace, some other chamfering or other parameters you can define. We can leave it as this. Alright, after we define this, we can click OK. You can see there are some tool paths generated from our first operation. Then we will need to drill all these tapped holes. So when it comes to create another operation, drilling, go to drilling, and there's a drill wizard, drill, and manual NC. I will do a drill wizard. Click on drill wizard, and then same thing here. It asks us to choose the library. Which is the tool, what kind of tool we're going to use. We click here, and the pop-up box about tool library. This time we're going to scroll down to the end. You can see there's a tabs, tools, and ANSI. We're going to choose tabs ANSI. And in this way, there's a lot of tools pop up. Well, we need, if you remember, our tapped hole is actually number 632. So we're going to choose 632, the drill, and click OK. You can see actually there's nothing show up, means the tool is not selected, but it's fine. We can, the geometry is already chosen. We can keep going, and then we can come back and edit the tool later. So just click OK. So in this case, you can see there is one operation. This is the wrap it out. It actually shows there's a cross, which means it's not defined. So we're gonna click edit and choose library tool. Make sure this time we choose go down to tabs NC and 632. Click on select. Now the tool is shown here, and also you can define the spindle speed. We can choose 500 RPM here, and then click OK. Then you can keep looking at some other operations, for example this, and see if you have your tool chosen. Now you can see it's all the tools have been chosen. Same thing is here. Alright, so we are good. And now see this under job there are two operations now, trace one and also drill wizard. In this case we already defined all our operations. One thing we can do is we can start do a simulation to simulate the tool paths. If you click, first make sure you select the job, and then do the simulation. And this is the one that you can actually change the adjust the speed. You maybe want to start with a little bit slow, and then move it faster if you want. So click this. Let me see what happened. Oh, maybe it's too slow right now. Okay, alright, it starts. You can see it start to mail these the numbers up. Now I'm gonna slow down a little bit. You can see that it's drilling the holes. And click OK. If you want to see the simulate again, we can do the same. Just stop and start. Increase the speed. Or reduce the speed. And then it's a drilling operation. Alright, so that's all the defining of the cam. Also, there's another function. It's a stock simulation. Stock simulation means you have a whole raw material stock. For example, if I choose a stock simulation, you can actually unclick this show hide bodies. This is the raw material with nothing. And if you click on this start and stops animation, make sure it adjust speed, it will start to mill on the actual stock. You can see how the numbers show up from the milling operation, and then the 3 drilling holes. Alright, so that's everything for this lab.